Okay, thank you very much, Kathleen. Hi, everyone. Thank you for joining this information session about ESS. I'm glad you're interested in our department, and you need to know that we're interested in you as well. Hopefully, this information session will answer some questions you may have about the PhD program. So we are a prime department of Earth System Science with one S in the country. We study climate change, environmental degradation, its causes, its impact, and solution to this problem. So if you're interested in these issues, then you are coming at the right place. We study the Earth as a system, so we have a whole range of discipline of Earth science in our department, and it's a very rich culture, interdisciplinary science that we cultivate in our department. So to do a PhD, you have to be passionate about science, and you need to know a few facts that we're going to try to debunk in this session. First of all, if you're accepted in a program, you will not have to pay for your PhD. You will actually be paid for your PhD. To get in our program, you need to talk to professors in this department to see if they accept PhD students and to see if they're interested in having you in the group. I also want you to know that in the research world, the top researchers in science are not coming from all the Ivy League institutions across the country. In fact, it's a very distributed spectrum that we have across science. We have people coming from all kinds of institutions, Ivy League or not Ivy League, it doesn't matter, because the top researchers sometimes are coming from minor institutions. We believe that there's a lot of talented people out there, talented students who would be well fit for a PhD program, but don't know about it, or I've never thought about it, didn't think it was for themselves. And hopefully this information session will help you think about that and convince yourself that maybe there is something for you in a PhD program. So I hope you enjoy this session, and thank you very much again for joining us today.
Great, thank you so much, Eric. All right, so I'm gonna go ahead and share my screen here, and we're gonna go through about a 20-minute or so presentation before we move on to the panel. So let me just give me a second here. Okay, so once again, welcome and thank you all for coming. So the purpose of today's program, as Professor Regnault mentioned, is to tell a little bit more about our department, as well as give you some tips for applying and what it takes to submit a competitive application. And I'm sure the grad students that are here can give you some tips of their own as well. So first of all, I know that many people here, I saw on the RSVP list that many people here are coming from a variety of different departments and backgrounds. And that's one of the really great strengths of our department, is that Earth System Science is extremely interdisciplinary. It focuses on how the atmosphere, land, oceans, cryosphere, and life are interacting. So we study all aspects of the Earth system in our department. And we come from ourselves, our faculty and our graduate students come from a wide range of backgrounds ourselves. So for example, myself, I'm a geologist and I study paleoclimate. But we also have faculty who have backgrounds in biology and chemistry and atmospheric, excuse me, sorry, just drink some water. In atmospheric science, in data science, and engineering. And we look for students from a variety of STEM backgrounds, as you may have seen in our flyer. So our graduate students come with bachelor's degrees or master's degrees sometimes. In everything from math and physics to ecology, to geology, to environmental science. And then in our department, we use a broad range of data and scientific approaches to better understand, predict, and solve the most urgent environmental problems of our time. And that also includes issues of policy and how humans are affecting the Earth system and affected by the Earth system. So I just wanted to read our departmental mission statement, which I think does a good summary of what we're all about here at ESS. So the UCI Earth System Science mission is to contribute through research and teaching to a fundamental scientific understanding of the Earth as a coupled system, to train the next generation of Earth scientists, that's you, and to inform and educate policymakers and the public at large. We envision a society that understands the impact of human activities on the global environment and the interactions within the Earth system that preserve the habitability of the planet. And we'll say a bit more in a minute about what specific research areas we focus on here at UCI. But first I want to say a little bit about UC Irvine in general, because I realize we have people joining today from all over the world. And I wanted to, who might not be familiar with where UCI is located. So UCI is part of the large University of California system, the biggest public university system in the US. And our campus is located here where the red star is. We're really conveniently located about halfway between Los Angeles and San Diego, just a few miles away from the coast. And so we're here in sunny Southern California. It's a great place to live as well as do research and study. So we have easy access to beaches, deserts, and mountains, all within a short drive. So if you like outdoor activities, we have something for everybody. We have a beautiful campus you can see in this picture right here. UCI is well known as being the top green university in the US. So we've won repeatedly the #1 cool school for sustainability in the US. So it's a really epicenter of climate science and sustainability research, not just in our department, but in many departments across campus. So there's a lot of collaboration both within our department and also more broadly. It's also one of the top research universities in the US, ranked #9 among public universities nationwide. And our ESS department is one of the highest ranked departments at UCI, ranked by the National Research Council as one of the top 3 programs in earth sciences. So, but I don't want this to intimidate you. We are a very welcoming and open department, and we have students that come here from all different types of backgrounds. Okay, so to say a little bit more about what we study in ESS, we typically divide our research areas into these 4 large categories, although I should say that there's a lot of overlap between these. So we focus on physical climate, biogeochemistry, atmospheric chemistry, and human systems. These are sort of our 4 key strengths, but within these, there are a wide range of research areas, ranging from climate dynamics and paleoclimate, oceanography, both physical oceanography and chemical oceanography, cryosphere studies. We have a really strong group of scientists, including Professor Regnault, who's the chair of our department, who study changes to ice sheets in Antarctica and Greenland and how those are being affected by human activities, how quickly they're changing. We study the global hydrologic cycle, ranging from the dynamics of how precipitation and extreme precipitation is represented in climate models and how we understand that, to how past rainfall variations were affected by different factors. We study biogeochemistry, including terrestrial and marine ecosystems and how they influence aspects of global biogeochemical cycles, such as the water cycle and the carbon cycle, but also other elemental and nutrient cycles. We study atmospheric chemistry, including human affected aspects of atmospheric chemistry, such as air pollution. We study the history of atmospheric chemistry through measuring trace gases in ice cores collected from Antarctica. We have a couple of research groups that really focus on biosphere-atmosphere interactions. So how land surface processes and plants are interacting and affecting atmospheric chemistry. And then human systems. So we also have faculty who focus, and graduate students who focus on energy, water, and agriculture. There are physical scientists who look at the impacts of climate and environmental change on these systems, as well as work on solutions. We also have a new faculty member who works on ecosystem services and sustainability related issues. So we have a really broad, diverse group of faculty. And so there's really something for anybody who's interested in studying the science of climate or global environmental change, whether you're looking at studying the processes, the impacts of climate change, or potentially the solutions. So we welcome anyone who's interested in these topics. And we also use a wide variety of methods. So myself, I do field work in Mexico and Southeast Asia, as well as have a isotope geochemistry laboratory here in the department. But there's many others who work solely, using computer models or data. And so I'll read through these, I guess, but basically, we have faculty and students who do field studies spanning the globe. We have, oops, sorry about that. We have students who and faculty who do research in Greenland, in Antarctica, in the Arctic. As I said, work in the tropics, as well as many who do field research more locally. We use ground-based, airborne, and shipborne measurements. So there's often faculty who are going off on field campaigns using aircraft or going on research cruises for months or weeks at a time. We use satellite and aircraft remote sensing as well, eddy flux tower measurements, whether that's in the Amazon or in the Sierra Nevada mountains really close to here. We use laboratory analyses. We have several state-of-the-art research facilities for geochemistry and other types of laboratory measurements. We use instrumental climate and paleoclimate data to study the Earth system. We use climate models and other types of modeling as well, GIS, and as well of growing importance is methods of machine learning and computer science to analyze the vast amounts of data that we have about the Earth system and use these cutting edge methods to better understand the planet. Okay, so moving on to a little bit of an overview of our PhD program. We have a very active and diverse and sociable group of graduate students, some of whom you'll get to meet here in a minute. We have about 60 current students. In addition to the research that they do, there's frequent social, educational, and community outreach activities that they participate in. Here's a group of our students on one of those rare rainy days in Southern California when we just happened to be out at Joshua Tree on a field trip a couple of years ago, but nevertheless had a great time despite the weather. And then just to give some highlights, again, I'll reiterate some of the things that Professor Reneau said, which is that we have a 5-year funding guarantee. That means you will not have to pay anything if you're accepted to our program. So you're given a written guarantee for 5 years of funding, and that includes summer salary, which isn't the case at a lot of universities. And the current estimated salary for the 2021-2022 academic year is estimated to be a little bit more than $36,000 a year. And this is funded typically through a combination of fellowships, research grants, and TA positions. We have, our faculty are really excellent at raising funding through grants from federal or state agencies as well as foundations. Students are also really competitive for fellowships such as the NSF Graduate Fellowship. But whether you get a fellowship or not, you are guaranteed this funding. And there's also a chance to get some of that funding through TA positions, which I'll mention a little bit more in a minute here. We also provide a moving allowance or relocation allowance, currently, I believe, at $2,000. And there's a number of different recruitment fellowships as well that are potentially available if you need extra enticement to if you're offered a spot at UCI and you need extra enticement to come. We provide comprehensive health insurance, including dental and vision, to all of our students. And one of the great things about UCI that's, I think, pretty unique is that we also have a convenient and affordable graduate housing, which is located right next to campus. It's really nice, and you're guaranteed to have access to that for at least 4 years. We also offer support in addition to all of the informal support from your peers and from faculty, as well as support from your faculty advisor. We also have a really active and long running peer mentor program for graduate students. So every incoming graduate student is assigned a peer mentor. And then we also have a ton of different professional development opportunities available both in the department and on campus. So whether you're interested in, more formal training and mentorship or teaching or science communication or community engaged science, there's a lot of opportunities for you, and our faculty tend to be really encouraging of their students to partake in those opportunities. In terms of what's actually required to do the PhD, we have a series of classes that you must take. So there's a minimum of 9 graduate classes that you would need to take if you're accepted. And those include our core classes, which are global physical climatology, humans in the Earth system, and global biogeochemical cycles, as well as a research practicum. And then you can choose from 5 graduate level electives, and there's a number of those available that you can choose based on your own research interests and needs. So typically most students take these classes during their first year. And then at the end of the first year, you have to take and pass a comprehensive exam. And on the way to your PhD, we don't have a separate master's program, but you do receive a MS degree once you've completed your coursework and the comp exam. And then typically you then would advance to PhD candidacy by the end of year 2. So that includes research presentation and proposal, as well as questioning with a committee of faculty, similar to what you would find at many departments. And then there is a requirement that students will TA or serve as a teaching assistant for at least 2 quarters. So UCI is on the quarter system. So we have 3 main quarters a year, which are 10 weeks each. So you're required to serve at least 2 times. And on average, our students TA about 6 quarters. By the way, this is a picture of President Obama speaking at the 2014 graduation, which was the 50-year anniversary of UCI. And he specifically used this talk to talk about climate change and how UCI established the very first Earth System Science department in the country. So that was pretty exciting for those of us that were there. And then here you can see a beautiful picture that was actually taken by one of our former graduate students of our building. Okay, so in terms of what is actually required for admission to our department, the application requirements include unofficial transcripts from your current and previous institutions, 3 letters of recommendation. Just a note about letters of recommendation. You should really make sure that you are asking people for letters who know you and are able to speak to your ability to succeed in graduate school. So we see the other side of this as faculty. Often we get asked for letters from students who never came to office hours, maybe never emailed us even, just took our class and we never met them. Maybe one of these big 100, 300 person classes. So I can't recommend more that you talk to your professors. It's not too late. If you're doing research, obviously people that you're doing research with, or maybe if you did a project in a class and talked with your professor, all of those people are much more likely to be able to write you a very strong letter that isn't generic and can give specific examples of your work and your enthusiasm and interest in science and your experience. So I definitely recommend that you think carefully about who you ask for letters. And of course, all faculty really, really appreciate it if you ask them for letters as early as possible and give them frequent reminders, especially right now in the time of COVID when there just seems to be so many more emails and everything constantly. So that's definitely one of the important aspects. You also need to include 2 written statements, a statement of purpose and a personal history statement. So one thing I wanted to clarify is that the statement of purpose is really about your long-term career goals and your research interests. Sort of what are you passionate about? What do you want to do with your life? And what do you want to research? The personal history statement should speak to who you are as a person, not as a scientist necessarily. So this is a chance for you to show one of the things that we look for when we're evaluating PhD applications is evidence of perseverance or resilience and motivation. So if you've overcome any challenges in your life, this is a great chance to elaborate on those. Similarly, we look for evidence of leadership and communication skills. And so this is a great way to elaborate on that and really include those details that are not evident just in the numbers of your grades. So this is another point. If you've had, periods of time or certain classes where maybe your grades weren't that strong, but there was a very valid reason for that, this is a good chance for you to address some of that because that will definitely be taken into consideration during our review. There's also an English proficiency exam required for certain international students. And then notably, we do not require the GRE tests anymore. We voted to drop the GRE requirement in February, I believe, this year. And so that is a permanent change. And so don't worry about that. In terms of the timeline, we begin reviewing applications on December 1st, but we'll continue to review applications that arrive after that. But of course, the earlier you apply, the better your chances are. We strongly recommend that you reach out by email to faculty members that you're interested in working with. So this is something that I think not everybody knows. Myself, I was a first-gen student. I had no idea that I was supposed to do this. So I just applied to grad schools and very luckily I got in. But now that I see it from the other side, I know that it's actually really important to contact faculty members whose research you're interested in. And we're used to this. We frequently get emails. It's really a great opportunity to introduce yourself, explain what you're interested in and why you are potentially interested in working with that particular faculty member. And also it's fine to ask like if they're considering taking any students or if they're looking for new students at the time. So I would recommend doing this soon if you haven't already, given that the application deadline is coming up. And as I said already, we all are getting a ton of email these days. And on that note, feel free to follow up with people if they don't get back to you. I don't take it personally. Often it may just be that it got lost and buried. So waiting a week or so and sending another email is totally fine. I usually appreciate it if it happens to me. Okay, so we begin reviewing applications. Then we also have a graduate visit day, usually in February. And unfortunately this year it's going to be a virtual visit because of COVID, but normally we actually invite students to come to UCI. So if you ended up applying a later year, maybe that would be the case. And then we distribute admission offers beginning in late February through early April after the visit day. So that's sort of the timeline we're looking at. And then I wanted to say a little bit about what our graduate students end up doing after they graduate from our department, which I'm sure some of you are interested in. So here's a selection of some of our alumni from recent years who finished their PhD. So I know that a lot of people maybe think that the only thing you can do with a PhD is go on to be a professor. And if that's what you would like to do, that's certainly something that many of our graduates do achieve. So this is one of my former students, Jessica Wang, who just graduated earlier this year. And she's now a tenure track professor at a community college because she became really passionate about teaching and got this great position at Bellevue College, Washington. We have other former students who are faculty at research universities like UCI. So this is Wei Mei, who graduated back in 2010, who's at UNC. We have a few of our recent graduates who've gone on to postdoctoral positions at universities. Forrest Hoffman here is a computational scientist at a national lab at Oak Ridge National Lab. And Diane Sanchez, who graduated last year, is working as an air quality specialist in Orange County. So we have our PhD graduates go on to a wide range of careers, not just in academia, but also in federal and state agencies, whether that's NOAA, NSF, NASA. We also have students who have gone into the tech industry, quite a few, or started their own companies. So there's a wide range of things you can do with a PhD. And you can learn more at this link here. I also wanted to address a little bit about sort of diversity, equity, and inclusion at UCI, which UCI uses the terminology inclusive excellence. So as a large research university in a very diverse part of the state, we have a strong commitment to inclusive excellence. We have an extremely diverse student population, both undergraduate and graduate level. UCI is actually a dedicated minority serving institution. So we are a Hispanic serving institution and a Asian American, Native American, Pacific Islander serving institution. I know that's a mouthful. And we also have a ton of students who are the first in their family to go to college. So UCI is actually ranked #1 in the nation for social mobility. And we have a lot of resources and programs available at UCI. A few of these I've just highlighted here that are especially relevant for graduate students are Decade. Decade is a campus-wide program that stands for the Diverse Educational Community and Doctoral Experience. So every department, including ours, has a Decade faculty mentor and Decade student representatives. And they organize social opportunities and mentoring and educational events to support diverse students, graduate students at UCI. There's a related program called Competitive Edge, which for certain students, you can come early for an 8-week summer research program the summer before you begin your PhD. We have our department ESS is also a partner in the AGU Bridge program. So the AGU Bridge program is a new program which is designed to help underrepresented minority students get accepted into PhD programs and provides them with some community and some support. And so UCI, our department was selected as one of the inaugural partners because we've shown that we are a supportive place for diverse students. And that this is a place where you can succeed. So you can learn more about that here. And that is actually another route to application. You submit a central application and then that application gets seen by all of the bridge partners. And then we have an active new SACNAS chapter, which is the Society for Advancement of Chicanos and Native Americans in STEM. And that's primarily a graduate student focused chapter here on campus. And then I also wanted to mention a new initiative, which has come about as a result of the events of earlier this year, which is the Black Thriving Initiative. So you can learn more about that on the School of Physical Sciences website. So our department, ESS, is part of the School of Physical Sciences, which also includes the departments of chemistry, physics and astronomy, and math. And each department has made a series of commitments and issued letters and statements in support of Black Lives Matter, but also has been working to actively enact many changes to make UCI a more welcoming place for students of color, including, for example, monthly social events for all of the Black students and faculty in our department. So I just wanted to put that link there. And now it is time to actually meet our student panelists. So you can see their pictures here. We have Dylan Ellsbury, Robert Fofrich, Joya He, Audrey Odwar, and Cindy Yanez, who are at various stages and in different types of research groups. So before we open it up for questions from everybody, I'm going to ask each of them to give a brief introduction about themselves and their history, as well as their current research interests. So why don't we just go from left to right? So we'll start with Dylan.
Hi, everyone. So nice to get to introduce myself. I'm actually a lifetime Californian. I went to the University of California